Hey, what's up, guys? This is Chung here. So today, LeetCode 1871, jump game number 7. Okay, so so this one is pretty interesting problem. So you're given like a zero index binary string s and two integers, the minimum jump and the maximum jump. Okay, and at the beginning, right, you're standing at the first index, which is index 0, right, and then which is 0. Okay, and then you can move the index within the range of the current index plus minimum and also the current index plus the maximum, right? Of course, you cannot jump outside of the array. And the next jump has to be equal to 0, right? And then it asks you to return true if you can jump to the end of the string or false otherwise, right? It's a very interesting one. So basically you have an example one here, for example, this one, the minimum jump is 2 and the maximum is 3. So which means that you can jump from the current one, you can jump from the current one plus 2 to the current one plus 3. So at the beginning, we are standing at 0, right? Okay, and then, so we have 0, 1, 1, 0, 1, 0, right? So at the beginning, we're standing at here. And then we can jump from 2 to 3, which means we can jump from here to here. That's the first range, the jump range we we have, right? And then from here onward, as you guys can see, since 1 we cannot do anything, but from here we can do another jump, right? So from here we can do another jump from 2 to 3, which is what? Which is the from here to here, right? Yeah, that's the second jump, right? Which includes the last one. That's why this one is true. Basically, from jump from here, and this range, since we have 0 here, from 0 to here, right? That's why the answer is okay. And the second one is this, right? 0, 1, 1, 0, 1, 1, 1, 0, right? So this one, still the jump range is the same, but the answer is false. This is because from here we jump to here, right? That's the first jump range, and here we have 2. So from 2 here, the range is like this. But in this case, right, both of them are 1, which means we cannot jump further. That's why this one is a false. So that's basically the description, right? And the constraint is like this. So 10 to the power of 5. And the first one is always 0, and this one, right? So the minimum jump and maximum jump, the range is the same as this length, which is 10 to the power of 5. Okay. So for this one, the naive approach, of course, is we can do a search basically, right? So basically, the first time the search range is from the minimum to the maximum, right? And then we can use a queue basically, right? So every time we push all the valid index, right, which is 0, it's also in the current search range, right? And then we push it into the into the queue, and then we pop it from the left until we have reached the end, right? So basically, for each of the current index, we check the current we check this range, and we find out anything that all the ones that has 0, and then we add that index to the index to the queue, right? But that one obviously it works, but it will TLE. So the reason being is that it's because this minimum jump and the maximum jump here, and that one seems like O of n time complexity, but instead it's actually O of n squared time complexity. So the reason being is this, let me do this, okay. Let me see here. Can I increase the weight of this color here. Anyway, so the reason being is that, let's say we have the minimum, right? So the minimum is like 1, right? And the maximum is like 10,000. In this case, let's say everything is 0, right? We have a lot of zeros, right? Yeah, let's say just everything is 0, right? And then the minimum is 1, the maximum is 1,000. So in this case, let's say that for the first time, right, we're standing at 0 here, right? And then from here to here, basically, let's assume this is a 1,000, 10,000. Basically, we'll do a for loop and we'll add all the indexes within this range to the queue. And then the second time we do a pop left, which is this one, right? So now this is the current one. So this one is current one, and then we do what? We do another for loop, right? So which means we're gonna do another for loop, like we're gonna loop through from this to here, still from 1 to 10,000, right? And then we're gonna check everything here. But obviously, assuming we have a visited set, right? Let's assuming we have a visited set that will skip all these kind of numbers here, index here. Instead, we'll only add this 0 into the queue, right? Even though, as you guys can see, even though we're only adding 1, but in terms of the for loop, basically we're doing like a very we have a process this kind of like indexes one more time, right? Same thing from here to here, right? And then from here to here, right? So as you guys can see, so every time we are we pop out like index, we'll do another for loop range, which is going to be of n square time complexity. That's why this approach will TLE. So which means we need to find a better solution, right? So actually, it's pretty clear that all we want to do is that we don't want to reprocess all this kind of indexes that we have already been checked before, because at the first time, right, when we're standing at index 0 here, we already check everything from this 1 to 10,000, and when this the first one popped out, right, when this one popped out, actually we don't need to check everything starting from here to here, because we know all the indexes before this 10,000 have already been checked, right? Actually, all we need to do is that we just need to check anything that's after this one, starting from here, right? Similar for this one, and the reason being is that let's say we have like another one, assuming we have this one, right? So that's the first range, and then we have 2 0 here. Let's say we have 2 0 here. It doesn't really matter the index, the position here. I'm just showing you guys. So since the range is fixed, right? So which means that let's say so starting from the beginning, we have this kind of range, and in this range we have 2 zeros. So which means from this starting when we process this 0 here, right? Uh we're gonna have like another range, right? Basically pointing somewhere to here, I guess, right? So that's the I mean, sorry, it doesn't have to be outside of the current range. It could be somewhere here, right? Could be somewhere here, depending on the range here, right? So as you guys can see here, uh, maybe somewhere here. So basically, as you guys can see, so everything is always moving forward, right? And when this like 0 got processed, so everything before here, before this index has already been checked, right? So which means that when we process this one next, right? So this is the next going to be popped out. When we popped out this 0 here, we can start from here instead of here, because everything starting from here to here, they have already been checked. And that's how we are gonna be avoid this kind of duplicate check here. Then obviously what we need, we need to maintain like the current maximum index we have checked, right? And every time when we pop out like a new index, we start from here instead of the I plus the minimum, right? Yep. So then let's start coding then. All right. So let me see. We have n going to be a length of s, and then we have a q, right? So since we're going to do like pop left, I'm going to use a dq here. We need a max, right? So that's the only thing we need here. And then while q is like this one, current equals the q dot pop left, right? And then for I in range of, so the brute force way is like this, right? So we have a minimum of jump. That's the starting point, and the ending point is like this, right? So like the current plus the maximum of jump to n minus 1 plus 1, okay, right? So this is the brutal, naive for loop here. Basically, every time we always start from this one, and then we stop to here. Basically, we're just following this formula here, right? And then here, as if I is equal to 0, and then we add it, right? We added the q dot append to I, right? And we can also do a check here. Basically, if the I is equal to n minus 1, right? And it's also like equal to 0, and then we return true, right? And then in the end, we do a return false, right? So that's the naive solution. Like I said, this one is a O of n squared, right? Because every time we start from here, which will kind of be slow. That's why what we need to do is here, instead of starting from here, we can do another start, right? We can just do a max. We can compare. We can compare this current plus minimum jump with the maximum plus 1, right? That's going to be our next start, next stop, next start. And then here, I just need to maintain this max current plus max jump. So the reason, actually, the reason we don't need to do a max of the previous one, right? Of the max of this one is because this max is always increasing, right? Obviously, this since the current is always increasing, this max is always increasing. Since we're popping from the left, right? So since this max jump is fixed, this one is always increasing. That's why we don't have to compare. So the key point for this solution is this one. Basically, we always compare the this maximum plus 1 with the current plus minimum, right? So because this one tells us the position we have checked so far, and we don't have to check anything before that. And I believe that's it. Okay, if I run the code here, accept it. Yeah, there you go, right? So it's passed because this one is like O of n time complexity, right? Because we will never reprocess the old index, which means we're always moving forward. That's why it's O of n. And yeah, I think that's it, right? This is how can I say it? The idea is simple, but the optimization or the improvement is a little bit tricky. But that's it. Okay, hope you guys like it, and Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.